Now it should be clear that we could keep numbering angles all the way around the circle. And if the9 angles within the first quadrant go from 1 through 4, then we're going to go from 5 through 8 in the second, 9 through 12 in the third, and 13 through 16 in the fourth quadrant. The points in the first quadrant, the next point will move over an angle equal to this one. Well, there's a symmetry between this and this, which indicates or proves actually that the projection of this point over here has to come to the same point as the projection of this point. And again, by symmetry, this point, number 6, will project to the same point on the y-axis as number 2. Now, I didn't label number 7, but I think most of you recall from earlier studies that between 6 and 8 we have 7. And of course I know that. Okay, point 7 here, so I've implicitly included 5 and 7. I don't want to clutter up the diagram with a lot of unnecessary labeling. Kind of did so over here. But this point is going to correspond, is going to project to the same point on the y-axis as this point. And of course now this point will come all the way around to the negative x-axis and project to the origin. So that between here and here, our y-coordinates will decrease through the same values they took as they increased from here to here. That's going to give us a point, well, for number 5, again, between 4 and 6 we have 5. We come up to the graph, and we're going to be at the same level we were here. And here, we could draw a little light line and get a point here. Here, come over to here, and down to here we get another point, and then here we get a point. And the symmetry of this picture simply corresponds to the symmetry of this graph about this, I'll draw it lightly, about this vertical line through our angle 4, which corresponds to the positive y-axis. And you want to think about that symmetry, how it reflects this symmetry, how you have a perfect correspondence, and how you would prove this symmetry, and then based on this symmetry, prove this symmetry. Okay? Well, if we continue now, we're going to go through negative y values. So I've got negative y values here in the same colors I have the positive y values. I didn't construct these. I could easily have taken the compass and done this and this and so forth and constructed these points, but I just kind of eyeballed them, so if they aren't completely accurate, that's why. Okay? And it should be clear that, I'm going to have another kind of an upside down symmetry here. It's going to give me something like this as I go through the third quadrant, and then as I go through the fourth quadrant. I turn around and come back up. And now I've got a complete graph of one cycle of a sine function. So this is one cycle of the sine function. Now this is really an unlabeled graph, even though I've labeled these angles from 1 through 16. Those numbers are just aids to help us keep track of where we are on the circle. Okay, so I really don't even want those numbers to be there, so I'm going to get rid of them. I'm going to come across here and just kind of wipe these numbers out. And I think while I'm at it, I'm also going to wipe out this implicit scaling of the x-axis. Normally I do this off camera, but and now the only points I have on the x-axis are the point 0, the point where the axis crosses the graph, and I don't have long enough straight edge, and I do want to use a straight edge to make this look pretty good. Well, no worse than necessary. Okay, now I have an unlabeled graph of the sine function. Okay, now the question is, how might we label this? Well, labeling is totally arbitrary. I could label this portion of the x-axis from 0 up through 479 miles. Or I could label it from 0 to 3/10 of a second. Have different meanings. Okay, I could label it from anything to anything, any scale at all that I want. I can use any scale to label this graph. And my vertical axis, okay? I could label my vertical axis from here to here as negative $700 to plus $700, or negative 7 Tesla to 7 Tesla. Okay, that'd be a really big magnetic field. Any labeling at all, depending on what I want to model with this sine function. And of course, I want to model something that is modeled by a sine graph. This could be temperature fluctuations above and below some median daily temperature. So maybe my graph would be from 12 p.m. to 12 p.m. or 6 a.m. to 6 a.m. or maybe just from 0 to 24 hours, and we decide what time of the day 0 stands for. And my temperature fluctuations could go 10 degrees above or 10 degrees below normal, whatever. Many, many different ways to label the graph, and numerous meanings for the graph of the sine function.